I, Vinay is going to explain about the Chapter 8, which is motion. It is for Class 9. It is lesson number 1. It is lecture number 6. Today's topics are acceleration, negative acceleration, uniform acceleration, non-uniform acceleration. First topic is acceleration. What do you mean by acceleration? Acceleration is defined as the rate of change of velocity with respect to time. Again, I tell, acceleration is defined as the rate of change of velocity with respect to time. It is denoted by A. It is a vector quantity. Mathematically, it can be expressed as acceleration A, change in velocity, it is as delta V, upon change in time, it is as delta T. And if in a given time interval T, the velocity of a body changes from u to v. Here u is the initial velocity, v is a final velocity. Then acceleration A is expressed as A is equals to final velocity v minus initial velocity u upon time interval t. So that is, we can say A is equals to v minus u upon t. That we can write other manner, at is equals to v minus u. So we can say v is equals to u plus at. This is called first equation of motion. So this kind of motion of an object is known as accelerated motion. The SI and CGS unit of acceleration are meter per square second as meter per second, and centimeter per square second it is as centimeter per second. So here you see the acceleration is taken to be positive if it is in the direction of the velocity, negative if it is opposite to the direction of the velocity, and 0 when it is moving with a constant velocity. Here example it is given. Here it is a velocity time graph, and this graph is parallel to the time axis, so the velocity is not changing, so acceleration will become 0. The velocity is not changing, so acceleration will become 0. In the second one it is given, the graph is in the above velocity time graph, the straight line sloping down represents that the body is in uniformly accelerated motion with negative acceleration. So the graph is moving, slope is in the downward direction. This represents about the acceleration. It is what? It is not the acceleration. It becomes the retardation. Retardation is explained as minus A. Here the third one it is given, velocity time graph. The graph is moving in the outward direction. This graph, the slope of the graph is for acceleration. It is uniform acceleration. So here I will tell about the retardation. If the velocity of an object decreases with time, then the body is said to have negative acceleration. In this graph, it is a negative acceleration because the velocity is decreasing with the time. This negative acceleration is also called retardation or deceleration. This is represented by minus A as it has been given in the graph, in this graph. Now uniform acceleration. If a body travels in a straight line and its velocity increases or decreases by equal amount in equal intervals of time, then the body is said to be in a uniform acceleration. So this graph is given, this velocity time graph and the slope of the graph in the outward direction. So this is what it is moving continuously as the velocity is increasing with the same rate, with the same time rate velocity is increasing. So it is a straight line. It is coming in the outward direction. It is the graph for the uniform acceleration. So these are the two examples of uniform acceleration: the velocity of a freely falling body, the motion of a freely falling body. So suppose it is a cap, it is my hand, and when I leave it, it moves down. So what is the speed? Speed is continuously changing, so it has uniform acceleration. One thing more it has been told you here. The motion of a ball rolling down inclined plane. The motion of a ball rolling down an inclined plane. It is the example you see here. It is an inclined plane this plane is going to make some angle theta with the horizontal plane. ये horizontal plane है, ये inclined plane है, ये हुआ 90 degree plane. So when a ball is start rolling down, so its velocity is going to change with respect to time. The ball has uniform motion when it rolls towards the downward direction. So this ball is uniformly accelerated. So now come to the non-uniform acceleration. Non-uniform acceleration, if the velocity of an object increases or decreases by unequal amount in equal intervals of time, then the object is said to be in a non-uniform acceleration. That is also called variable acceleration. So for example, here it is given the example, and this is the graph, velocity time graph. Graph is a curvier line. So velocity is increasing with respect to time, but time is fixed, but velocity is different. It is coming different. So this graph is going to tell about the non-uniform acceleration, and it is also called graph for the variable acceleration. So here there are some examples. The moment of a car on a crowded city road. So when the car is coming in the crowded place, the speed of the car decreasing or increasing. So this is the non-uniform acceleration of the car. Like that, the motion of the train. If the train is approaching to the station, so its velocity will decrease. When the train is moving from the station, its velocity again change. So the velocity of the train is decreasing when it is approaching to the platform. When moves from the platform, so its velocity is increasing gradually. So the motion of the train is non-uniform when it leaves the station or when the train is entering towards the platform. Here it is given according to this graph. You say here it is a graph. 2 points it has been taken on variable accelerated bodies graph. One is A, other one B. If two perpendiculars drawn to the velocity axis and to the time axis, so from A it is T1, and from A on y axis it is V1, and from B on time axis it is T2, on y axis it is at V2. So here, what is the difference between them? It is delta t. Difference between them is delta v. So the slope of the graph between A to B is slope is equals to V2 minus V1 upon T2 minus T1. So A is equals to delta V upon delta T. So any 2 point on the graph we have to take. By that we can find out the variable acceleration, the particular acceleration. The acceleration we can find out of the graph. So this is what for two particular moment of the graph we have to find out the points we have to take, and then we can find out the slope of the graph with the help of this type of variable acceleration graph. It is the velocity time graph. So thank you very much. Next time I'll explain about the next topic.